important thing here is just to consider that these 2 degree of freedom systems are just coupled ordinary differential equations, right? So last time we went through a whole lot. We built our coefficient matrix. We said, all right, mode shapes can't be 0 because that's trivial. Coefficient matrix can't be 0 because that's trivial. And then we said, well, I have to have an inverse. Otherwise, I could, make that equation equal 0. So now I can't have an inverse. Otherwise, I would end up with another trivial solution. So if I can't have an inverse, I take the determinant, set it equal to 0. And we slowly kind of walk through a set of engineering problem-solving approaches, knowing that we have a physical system. We threw away our negative frequencies. They don't mean anything. We did all of that, right? From an engineering standpoint, it's a very good way to solve an ODE. From a mathematical standpoint, you can directly solve the ODEs. ODE using, well, let's just say using Kramer's rule. Did you guys go over that in your ODE class? Who remembers Kramer's rule? Who remembers the word? Who thinks they've heard of Kramer's rule before? Okay, so most people. We're not going to do it here, right? I typed it up once for a 2 degree of freedom system with damping, which you'll notice we haven't done any damping up to this point in 2 degree of freedom systems, right? So damping will give us a C matrix. We just haven't discussed it yet. But you can absolutely build it. You can build your equation of motions, and then you can take the Laplace of them in case you miss the Laplace transform. And then you can solve for x of s. You can put it into a few expressions, and you get that d1 over d, d2 over d, that infamous part of Kramer's rule. You can solve your D matrices. You can merge them all back together, and you can get an expression that is quite long. Probably not really what you're wanting to do. The only reason I show it, this won't be on the exam, it won't be on the homework, this is just a look and move on, is that there are ways to directly solve this. And at the very end of this chapter, we'll show you there's a way to directly solve this using MATLAB, right? You just solve the ODE. Is it efficient? What, in terms of your time, yes, but not efficient in terms of like computational time. But it is nice to know that you can just directly solve the ODEs. And if you wanted to, you wouldn't have to work through those mathematical steps and assumptions that we made last time, right? Because it can be a little bit confusing to know what you can assume away and what you can't. So you can directly solve these ODEs.